Hello students, today we will take a very important problem of nodal analysis. So you will see here is 3 ohm resistance, and 6 volt battery, and here is also 3 ohm and 3 ohm resistance and 12 volt battery. The problem is that you cannot tell about these two resistance, these are in series or in parallel, and here is also the same. But you have I will tell you the concept in the same branch. You can interchange the position of battery and the resistance, and here is also the same. So if you put this 3 ohm resistance in the place of 6 volt battery, then these two resistance will become in series, and here is also the same. 3 ohm and 3 ohm will are in series, then will become 6 ohm, right? So now we are drawing the equivalent diagram. Okay, so now we will draw the equivalent diagram. So what will be the equivalent diagram? You will see here, this is 6 volt battery, and here is 6 ohm resistance, and here is also 6 ohm resistance. You know how it become 6 ohm? Because we have replaced this 3 ohm in this place. So 3 and 3 will become 6, and here is also the 3 and 3 will become 6. So this is 12 volt, right? And this is also 6 ohm. So in nodal analysis, at any point we consider zero potential, so that we can write the potential of other points. So if we write 0 volt at this, if we consider 0 volt at this point, so we got maximum point having zero potential. You got 3.1, 2, 3 points. Okay, so let us consider zero potential at this point. So this is 0 volt. This will also become, because there is no resistor or any other circuit elements. So here will be also 0, and here will be also 0 volt, right? So if you are going from negative to positive terminal, then the potential will increase by 12 volt. So potential of this point will become 12 volt. And similarly, when we are going from negative to positive terminal, then potential of this point will also increase by 6 volt. Sorry, 6 volt. Clear? So now we have unknown the potential of this point. So let us consider this as x. Okay. So this is the junction point on which the current approaching to this point, the sum of current approaching to this point are going away from this point will be 0. So you can write, you can apply KCL at this junction point. Okay, so by KCL, let us consider the current going away from this point is I1, and here is I2, and let us consider this I3. So you can write sigma I equal to 0, means I1 plus I2 plus I3 equal to 0. What will be the I1? This current is going from this point, then this point will become higher volt, means x minus 6. And current will be equal to potential difference divided by resistance. So what is the potential difference? X minus 6. So this is x minus 6 over resist. What is the value of resistance? Which is 6. Okay, and plus what is the I2? Current I2 is higher volt. We have considered this point as a higher volt, right? Means x minus 12 over 6 plus. Now here we have considered this point as higher potential because the current always flows from higher volt to lower volt, right? So you can write the potential difference between this resistance is x minus 0 over 6, and this is equal to 0. So now you can write this, okay? So x minus 6 plus x minus 12 plus x and divide by 6 एलसीएम आ जाएगा, वो 0 होगा नहीं, right? That will be not 0. So now you can write this 3x, okay, and minus 18 are equal to 0, means x equal to 18 by 3, means we will got 6 volt. So now we want to calculate the current in this circuit. So what will be the value of current? Okay, current I1 will be, if this is 6 volt and this is also 6 volt, so their potential difference is 0. Current will be equal to the potential difference divided by resistance, means 6 minus 6 over resistance is 6. So this is 0 by 6, which is 0 ampere. What will the value of I2? Okay, so this is 6 volt and this is 12 volt. The current will always flow from higher potential to lower potential. Current will flow in these directions, right? But we have considered this. If we consider this direction, then current will become negative. Then negative current means the current will not flow in this direction but flow in this direction, right? So if we have considered this point as higher, then you will write 6 minus 12 divided by 6. So you will get minus 6 by 6, which is minus 1 ampere. Minus is sign is showing the current will be not in direction but it will be in this directions. What is the value? What will be the value of I3? I3 will be, we have considered this as 6 minus 0 over resistance, which is 6. Then you got 1 ampere. Okay. So did you clear the concept how to apply nodal analysis in any circuit, right? Okay, so note down all this, and now we close our topic.